Good morning. We are going to see the fourth problem in Centroid. Find the centroid of a composite section. Okay, so here is the composite section. Now, in this problem, we are going to find two differences to the previous problems. The first difference is the position of the coordinate axis. If you look at here, y axis and x axis, this is the origin. Now, if you look at the origin, this origin is located approximately at the geometric center of the object. Geometric center of the object. If you look at my previous problems at all, this y axis will pass through the left extreme edge. Similarly, this x axis will go through the bottommost edge. Okay, so this is what we discussed in the previous problems. But here, these two are passing through the object, through the geometry center of the object. This is the first difference. Then, second difference is when we make the final shape, you know that we only added the objects. If we take my previous problem, this is the final shape. In order to get this final shape, we added, see here I have used the addition. Okay, one square, one triangle, and then one semicircle. We added these three objects to get the final shape. But here first time I'm going to introduce subtraction in getting the final shape. Okay, this is what I am going to do. Yeah, square, then quarter circle, and then a triangle. And you see here I have introduced the subtraction. So this is the second difference. Now we are going to check whether the given object is axis symmetrical one or not. Okay, now so this is the object. I am going to cut this object using y axis by passing like this. Okay, so this is the y axis. Now this is one part, this is second part. If you see here, these two parts are not symmetrical with each other. Okay, similarly I am going to cut this object using y axis like this. Now this is one part, this is second part. Now you see here, these two parts are not symmetrical with each other. So I cannot find x bar and y bar directly, since this is not symmetrical with respect to both x axis and y axis. There are three steps to find the centroid. The first step is you have to divide the composite section. Okay, divide the composite section, because the given composite section is not in regular shape. When I say regular shape, square, rectangle, triangle, circle, etc., etc. So you have to divide them in such a way that finally the individual shape should be a regular one. Okay, as I told you earlier, here I am going to use the subtraction to get the final shape. So I am going to take a square. Okay, so this is the square, this is the square. Then I am going to remove this portion, a quarter circle portion. Okay, second one. Okay, if you look at here, this one, this one. Then I am going to remove a triangle at this side. So this is my third one. So finally I will get this shape. Okay, so this is a square, a quarter circle is removed, here a triangle is removed. Finally I will get a final composite shape. Okay, you see here I have used subtraction, here also subtraction, and here also subtraction. This is our first problem like this. Now once you divide the composite section, then you have to know the formula for to find the centroid in each individual shape. I have already shown you a tabular column for this one. Again I am going to show you the tabular column. Here some of the common sections are here. The first one is a square. This is x axis, y axis, and this is the centroid. Now from y axis to this centroid, x bar equal to a by 2 and y bar equal to a by 2. Now area is again a square. Okay, then the second one is a quarter circle. This is the quarter circle, and here this is the diameter and y axis is passing through. This is another diameter where the x axis is passing through. Now x bar equal to 4r by 3 by, where r equal to radius of this quarter circle. Again y bar equal to 4r by 3 by. Make sure that here the y bar is referred from this end. Okay, this radius end. Okay, and here also this radius end. And then finally the area, by r square by 4. Okay, and then third one is a triangle. As you know that this is a triangle, this is the centroid, x bar equal to b by 3, where b is nothing but this, the length of this side, and x bar y bar equal to h by 3, where h is nothing but this side. Now the area of this triangle is half BH. When you deal with the triangle, you have to be aware with one more steps. I already discussed in my previous problem. Let me take a triangle where this is the side of the triangle B. This end is point end and this is the line end. Now distance between point end and G is 2b by 3. Okay, 2b by 3, and the line end to the G is b by 3. b by 3. This you have to be aware of it. Now we will go to the second step. In the second step, we have to find the x coordinate, y coordinate, and a1 for each and individual section. My first section is the square. Okay, and to draw this separate diagram, you refer this original composite section. Okay, first check the dimension. You see here 20 and 20, so the one side of the square is 20 plus 20, 40. Similarly, if you look at the other side, here you have 20 and here you have 20, so 20 plus 20, 40. So this side also 40, this side also 40, so it is a square. So this is what we have represented, 40 into 40. Then second work is the position of the coordinate axis. For that also you have to refer the original composite section. So this is the position of the coordinate axis, y axis, and through this one, this is the x axis. Here also if you look closely, this O is passing the center portion of the square, the geometric center of the square. So here I have represented it. This is origin, whereas this is G1 is the geometric center of the square. Now I want to know the x1 and y1. x1 and y1. If you look closely, O is the origin through which y axis is passing and the x axis is passing. But the G1 is also lying in the same geometric center O, the origin. Both origin as well as G1 are lying in a same point. So in this, I cannot get the answer for x1 because this is 0. The distance between G1 and y axis is 0. Similarly, distance between G1 and x axis is also 0. Very important information to know. But area is again the same, A1 equal to 40 into 40, 1600 meters square. Okay, please look at this information more and more, it is very important. Then the second one is a quarter circle. Again we have to go back to the composite section. This is the quarter circle. Let me take this one. Here the curvature end, if you take this as the curvature end, one end of the curvature is touching x axis and other end is touching the y axis. So this is y axis, this is y axis. So the other end is touching the y axis but on minus y. Okay, so this is the second area we have to consider. I have taken here. This is the second area. As I told you earlier, the one end is touching x axis, other end is touching minus y axis. This is the G2. Okay, centroid position. This is y2 and this is x2. Now to get the answer for x2, you see here x2. Okay, so x2 is nothing but distance between this y axis and this G2. So this is x2. But in my but we know that now this is radius end and this is centroid. From radius end to centroid it is 4r by 3 pi. But in this case this is y axis, but where the curvature end is touching, this is the radius end. From this to this it is 4r by 3 pi. That's what here also we studied. From this radius end to G it is 4r by 3 pi. So from this radius end to G it is 4r by 3 pi. But I need to know this end, this x2. Okay, So the best way is the total length is 20, and then I am going to subtract this 4r by 3 by, so I will get the answer for x2. So this is what I have done here. 20, this 20, then I am going to subtract this portion 4r by 3 by, so I will get the answer as 11.51 meter. Similarly, for finding the y2 also, you see here y2 is nothing but from this radius into the g, it is 4r by 3 by, okay, but here this is the radius end. From radius into the g, it is 4r by 3 by, but I want to know this distance y2. So I am going to consider first this 20, then subtracting this one, it is 4r by 3 by, then I will get the answer for y2. So this is what here I have done. y2 equal to 20 minus 4r by 3 by, and I am going to get the same answer. Here you see here minus, because G2 is located in the fourth quadrant. In the fourth quadrant, y coordinate is becoming a negative. Okay, so here I have put minus, then area. Okay, area is by r square by 4. Here I have put minus because I am going to subtract the area. You see here I am going to subtract the area, so you have to put minus. Very important data, very important information. Here also I have put minus. Okay, very important information. Then the third one is a triangle. Okay, and again refer the same composite section. So this is the this is the triangle I have to remove. Okay, and you see here this end, one end is touching the x-axis, other end is touching the y-axis. So this is what here I have drawn. This is the triangle, and one end of the triangle is touching y-axis and other end is touching the x-axis. Now this distance is referred here as 20. Similarly, this distance is referred here as 20 meter. So 20 into 20 meter, this is G3. Now I want to know this distance x3. Okay, as I shown you here already, you see here from point end to TG it is 2b by 3. Okay, from line end it is b by 3, but here this is the point end. Okay, so 20 into 2 by 3, so here b is nothing but 20. Okay, and here minus because the quadrant G3 is located in the second quadrant where the x-axis is in the negative side. Okay, similarly for finding the y3, again here this point end is touching x-axis, so 2 into 20 by 3, so this is the answer. Here y-axis is positive because it is in the second quadrant. Okay, and A3 is equal to half pH. Here you see here I have put minus because I am going to subtract the area. I am going to subtract the triangle area, so you have to put minus. Very important data. Then the final step, the third step is using the summation formula. I have only 3 areas, so I have gone to only 3, that is x1 a1 to x3 a3. Okay, only 3 areas. Just to substitute the values, make sure that the negative values are substituted accordingly. For example, okay, here here y2 and a2 is minus, so when you substitute here in the place of a2, substitute as it is minus. Okay, similarly if we see here x3 is minus and a3 is minus, substitute here accordingly. So this is x3, this is a3. Okay, don't touch the equation, just substitute the values as it is in the previous steps. Okay, when you substitute and calculate the answer, you get the answer for x bar is minus 0.87 meter. In the similarly, substitute the values of y1 and a1 according to the previous steps. Okay, don't touch the formula. Okay, and if you calculate, you will get the answer as 1.955 meter. Okay, thank you friends. We will meet in the next video soon. Thank you.